Hello, everybody. This is the part of the lecture where I look at you and I say, please put your pencils down and just follow me on the blackboard because I'm going to be writing a lot of information and I want you to pay attention to it. Well, that's not going to happen. But what I can ask is for you to maybe put your pencils down and just have a look at what I'm about to discuss, because what we're going to talk about is where the energy for exercise comes from. Every time the muscles contract, they use ATP. ATP is the energy currency of the cell. And depending on the intensity and duration of the exercise, the ATP may be coming from the cytoplasm, it may be coming from the mitochondria, and also depending on the person's diet. So there are three factors that can affect what provides energy for the muscle to contract: diet, intensity of the exercise, and duration of the exercise. I want you to have watched the two videos that were posted before you look at this, because I addressed some of those issues in those videos. The energy for exercise is going to come from within the cell. So we've digested, absorbed, and now we're going to metabolize energy. The preferred energy source for the muscle tissue is glucose. And again, depending on the diet, the intensity, and the duration of the exercise, that glucose is going to provide ATP either aerobically or anaerobically. If we're getting ATP from what's called anaerobic respiration or anaerobic metabolism, it's going to come from the cytoplasm. The cytoplasm is the part of the cell that contains all the other organelles. And this picture shows you the different organelles that are found inside the generic cell, which of course there are none. But during anaerobic respiration, ATP will come from the cytoplasm. During aerobic respiration or aerobic metabolism, those ATPs are going to be produced in the mitochondria. First, we'll look at anaerobic respiration, which results in the production of lactic acid. And while I don't want you to remember specific numbers, I'm just putting here that lactic acid will give us 2 ATPs per molecule of lactic acid. This is the pathway by which ATP is produced through anaerobic respiration. Recall, we're in the cytoplasm, and we start with glycogen because that's a storage form of glucose in the cell. Glycogen is broken down into glucose, and glucose is a 6-carbon molecule. Glucose is then broken down into a molecule called pyruvate or pyruvic acid, which is a 3-carbon molecule. Again, I'm not asking you to remember these specific numbers, but I want you to know what this pathway is and why it's occurring. In the absence of oxygen, pyruvate cannot enter into the mitochondria. So think about what kind of exercises we're talking about. We're talking about high-intensity, short-duration exercises, things like sprinting, weightlifting. Those are anaerobic exercise. So there's not a lot of oxygen in the bloodstream, and there's not a lot getting into the cell. Again, because the cell prefers glucose for energy, it's breaking down those glycogen stores, but it can only get to pyruvic acid because in the absence of oxygen, we can't get into the mitochondria. However, we can get ATP from pyruvic acid. Pyruvic acid will form lactic acid or lactate, which is another 3-carbon molecule. And lactic acid can be used to provide ATP for muscle contraction. Have any of you ever experienced muscle fatigue while you were performing high-intensity exercise? Well, that could be due to the lactic acid building up in your muscle. It's kind of an evolutionary process whereby if lactic acid increases in the muscle tissue, the muscle fibers begin to fatigue, and that causes pain. That causes you to slow down. Once you slow down, then oxygen is getting into your bloodstream, and the lactic acid will resynthesize glucose. The muscle doesn't have the enzymes for this process to occur, so lactic acid leaves the muscle, it travels to the liver, and in the liver it will resynthesize glucose. This recycling of glucose is what is referred to as the Cori cycle, which was discussed in one of the previous videos. That glucose can then either go back to the muscle tissue and be used for exercise or go to other places in the body that it may be needed. This is the production of ATP through anaerobic respiration. Anaerobic means in the absence of oxygen, and it occurs in the cytoplasm of the cell. Aerobic respiration results in the production of 36 to 38 ATP per molecule of glucose. Again, you don't have to remember those numbers, but if we compare it to the amount of ATP produced per molecule of lactic acid, you can see it's a lot higher. 2 ATPs are produced during anaerobic respiration as lactic acid is broken down for energy, but 36 to 38 ATPs are produced during complete breakdown of glucose, not just to pyruvate, but once it gets into the mitochondria. Aerobic respiration gives us a lot more energy for exercise. But think about it. Aerobic exercise tends to be lower intensity exercise that you can do for longer periods of time. So the body produces more ATP.